Welcome to the Passivhaus podcast, brought to you by Passivhaus Accelerator, a catalyst for zero carbon building. For news, inspiration and connections from all flavours of Passivhaus, check out passivhausaccelerator.com. Sign up to receive regular updates about events, get your questions answered and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passivhaus journey. We hope to see you at one of our weekly Passivhaus Accelerator live webinars. In the meantime, here's this week's Passivhaus podcast. Welcome back to the Passivhaus podcast. I'm Matthew Cutler-Welsh, coming to you from Auckland, or just outside of Auckland actually, this week in New Zealand. And I'm joined this week by Zach Semke. How you doing, Zach?
I'm well, thank you.
And lovely to see Ilka Cassidy. I haven't seen you for a few weeks. How are you?
I'm doing well. I've been on a conference marathon. I feel like hopping conferences. Yeah. I've been very busy doing that.
I'm slightly jealous, but I also know that you've been working very hard. I hope that at some stage we'll get to hear a little bit about all that you've been up to and all the great people you've met, because you've been at Greenbuild and also the Passive Forum.
Yeah, the Fierce Pro Forum in Rhode Island and Providence. And I also went to the Build Show in Austin, Texas.
Yeah.
Very busy.
Busy. Yeah. All right. So, well, we'll hopefully get to talk to some people that you met over the coming episodes and learn a bit more about all that stuff that's going on. We do have a great interview to get stuck into, a bit of a panel interview this week. Before we get into that, Zach, we've got a few people to thank.
We do. First, I'd like to thank Zola Windows, who is our Accelerator Partner of the Week. So Zola is making all of our programming possible this week. I'd also like to thank our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. And thanks to our champion sponsors, Buizo, Icon Windows and Doors, Intelligent Membranes, and Source 2050.
All right, Ilka, can you tell us about the panel that you got together to have a chat with?
Sure. So I was actually really, really excited about this interview because what I wanted to talk about was the design to manufacturing and assembly process and how different manufacturers really approach that, because everyone does it a little differently depending on how they're set up. And in particular, I was really interested in hearing what the intersection is with architect, builder, and engineers, because what they typically do is not necessarily thinking about producing panels at the end. So I was joined by Jonah from B.Public, by Chelsey from Geologic, and by Abby and Angie from Quantum Passivhaus.
Excellent. All right. Well, let's get into it, and we'll catch up afterwards.
Welcome to the Passivhaus Accelerator podcast, and I'm really excited to talk to Angie Horner and Abby Xerri from Quantum Passivhaus, Chelsey Effinger from Geologic, and Jonah Stanford from B.Public.
Thanks for having us. Thanks for having us, yeah.
So we are going to discuss the design to manufacturing and assembly, the DFMA process, and how it intersects with the work of the architect and builder team. Because what the manufacturer needs to produce panels is a 3D model and drawings that show basically every single stick and lumber and fasteners and everything that goes into that envelope. But that is not necessarily what an architect's plan set or model shows. So this is basically what we're going to be talking about. But before we get into that, let's talk about what you and your companies do, because I'm sure we'll find some different approaches to this topic depending on what your approach is. So let's start with Angela and Abby.
Hi, well, I'm Angie Horner, and I'm one of the co-founders of Quantum Passivhaus. Abby, who's also with us, is the other half, so the other co-founder. My work here has typically been more involved with the energy modeling and such. So it does come into a little bit of everything that we do, but more recently training and education within our team, and then extending out to the people that we work with.
Hi, everyone. Thank you for having us, and great to see everyone else on the panel here as well. So my name is Xerri, as Angie mentioned. I am the co-founder, president, and general manager of Quantum Passivhaus. Quantum is an innovative always, as we like to put it, a company dedicated to developing new builds and retrofit panels and components. We do focus on building science, as our goal is always to achieve the highest standards for low carbon, net zero, and other performance methods.
Thank you. How about Chelsey?
Hi, everybody. Thanks for having me. My name is Chelsey Effinger. I work at GoLogic. We are based out of Mid-Coast, Maine. We also have a shop in Southern Maine. We have been building Passivhaus standard buildings since about 2008. I came onto the team in 2020 as a designer and CPHC. Shortly before that, we started leaning into panelization a little more. So I've been with the company since panelization has been their focus. So now I do the energy modeling. I have a HVAC interest. So I usually do the mechanical and ventilation plans, all the certification through Passivhaus if we have a project that goes through that. And I head up a team of four really wonderful designers. So super glad to be here. Excited to hear what you guys are all up to.
I guess I'll go next. Thanks for having me. My name is Jonah Stanford. I'm one of the co-founders of B.Public Prefab based in Santa Fe, New Mexico. And we manufacture here in northern New Mexico, and then we also work across several other states, working with other manufacturers to serve other regions as well. And I am the Chief Technical Officer, so I sort of sit in the middle a lot of times between both the design process and manufacturing. And prior to launching B.Public, which we've been around now for about 6 years, I had a Passivhaus architectural firm where we were actually stepping more and more into prefab. So B.Public was really sort of based on a lot of the lessons learned from that process. So kind of interesting to be on this panel today because I was very, very much on the other end of it for a long time as well. So, and it's very interestingly complex, actually, and diverse depending on, the specific sort of our specific approaches that this panel certainly has across the process.
Awesome. Thank you. So Jonah, maybe let's start with you. So can you explain how B.Public approaches the panelization? Because for you, it's basically you have a very defined standard panel, correct? And what does that mean in terms of, modeling and design to manufacturing? And how does that affect how you work with architects?
Yeah, thank you. We did launch with what we really thought would like as a kit of parts. So standard panels, really trying to simplify that engineering and shop drawing process. And really what we found was that that's not what the market was ready for, honestly, at this point. And I think in larger quantity projects, then that does make sense. Like there's sometimes you're able to leverage standards within a project, but that what we've moved more towards is, and certainly we have standards like, we flat pack, or, we're panelized assembly. So we're flat packing everything. So no panel is wider than 8 feet so that we're not doing, wide loads and shipping and so forth. But really what we've leaned more and more towards for a lot of reasons is maintaining consistency in our construction detailing. So that is what we found more than say the dimensional parameters within a panel. So that's what we found is most important for maintaining good thermally bridge-free construction details, consistency in our bill of materials, and production processes. So
you manufacture your own panels, but you also work with different manufacturers, right? And what I feel like is really interesting about that is that you do have to communicate with different manufacturers, right? And as soon as you kind of we're out of the kits of parts approach, you have to basically tell them, or how they build the panel. So do you draw this? Do you create the 3D model and the panel drawings and assembly drawings, or is that the manufacturer that you work with who does that?
It can vary. It depends a little bit. It depends on both our workload at B.Public and also just the specific requirements of that shop. But we typically, like our initial phase will be an assembly set that sets the overall volumetric, parameters and dimensional parameters. And then it is also serves as the base for the division of panels. But I think you're absolutely right that, a set of shop drawings will potentially have all the technical information there that a computer could build it, right? But the sequencing that shops have for production really dictates how that information wants to be laid out on a set of shop drawings, like in the orientation, whether you're looking at the bottom of the panel or the top of the panel. And also, just what we've seen working with different shops is just because all that information is there, and this is the same with working with outside architects or engineers or clients, just because the information is there technically doesn't mean that it's being conveyed, right? Or that it's fully understood. And so anytime we're working with a new shop, that onboarding process with a new shop is pretty extensive. And usually I'm visiting that shop, working with them, or they're sending people to our shop. And there's also, as everybody knows, there's so many things that are not in the shop drawing sets, like it's the framing and sheathing, all the structural components. But what about the detailing for tapes, membranes, how you're treating certain conditions? That really comes down to craft and so illustrating. So our guidelines for other manufacturers, there's shop drawings, but then we have, a 20-page sort of production examples. That's a lot of photographs and things like that of our production, just so that we can convey those details correctly. And, because those are what makes the big difference past structure, right? Those are our thermal bridging, vapor control, captive air spaces, all those things that really do ultimately have a long-term impact on the panels.
Yeah. Yeah, and what's really interesting about this is it's all about communication, right? Even the whole design to manufacturing and assembly, whether you do it with a document like you just described, or if it's through like a very detailed 3D model, it's all about conveying information from one point to the other, correct? So what software do you use for the 3D modeling part, and how does that communicate with the architect's software?
Yeah, good question. So it does vary, of course. So about 20% of our projects are designed in-house, and then about 80% of our projects are coming from outside architects, engineers, clients specifying our assemblies. And so it varies widely. Regardless of sort of the source files, we work in Revit. And so we would create, there's families or assemblies, and we're exporting typically those as IFC files to the architects that they're able, depending on where the project is, if it's at schematic, then we're optimizing that assembly under sort of standard advanced framing, like 24 inches on center and things like that. And they're coordinating against it. If the project is like in DD phase, like design development phase, then we're really coordinating against their file. But so they're typically importing that IFC file, verifying sill heights, not sill heights, but like plate heights, clear areas, rough openings for windows and doors. And then for shop drawings, we use a plugin for Revit called AggieCAD, which has really been successful for us. So it's always native in Revit, which has really been positive. And Revit has, back to the communication factor, Revit has such great capacity at communicating visually assemblies. So that's really been positive, because we have shops that are almost fully automated and others that are fully manual. And so really needed to work across those.
Yeah. So, Angela and Abby, do you have a lot of outside architects or do you do mostly everything in-house?
Well, if I may, well, we love the opportunity to collaborate with architects, developers, and builders. I think it's essential to getting the product that's needed for the environment everywhere. So we have an exciting process that allows us to do that well. But because we do most in-house, everything that we do is in-house. We have dedicated engineers to our firm. We have a large design group so that we can also control our shop drawings. This way, we're able to bring solutions or opportunities to be a solution to a challenge. We can do it internally, we can do it quickly, and we know how it fits well and cost effectively with our systems. And because we offer a variety of panels, it's critical that we have this type of collaboration internal. We are offering not only new panels, but obviously for this call, our podcast, our retrofits, but we're also focused on combustible, non-combustible, low, mid, and soon high rise. We're in the development of our own proprietary components for attachments. And we also enjoy the consistency or predictability of having a controlled environment for our window door installations, which is new for 2025. Happy to share on this podcast, and a variety of installations that we're able to do. So we have a very specific assembly line and production facility so that we can be diverse and flexible and ready, not even for what challenges we face now, but ready for challenges 3-5 years from now. Did you want to add to that?
Thanks. Sure. I'd love to. Thanks for sharing that, Abby. When I think about how us as a company, I think, and for probably everyone in this field, collaboration is key.
Mhm.
And I think that quantum is sort of almost like with COVID coming out of our shell a little bit now and really wanting to reach out. It's almost like a replica of COVID, wanting to reach out to everyone, both designers and builders. So I see us doing a lot more outreach. And I think probably everyone on this panel would agree. As far as the design to construction connection, early is definitely ideal. It's always going to be, your earlier collaboration starts, the better it is. So some of the things when we do outreach to people, some of the things we know that they're going to want to know about in their design is like, where's the load points in our system? So with our standard details, what's our load points? What are the dimensions? What are connections like? Any tested values, whether it be measured thermal bridges or water penetration or air penetration? Where's the air barrier? Where's the vapor control? And if I missed anything, you guys, that you see is everyone else on the panel that you think would be key for people to know, please pipe in. That's just my short list. So yeah, I see us really wanting to communicating clearly about what we offer, but also collaborating with others. Jonah, since you work with other manufacturers, would love to take up that conversation later as well. I think the collaboration is just the way to be. And then also just to add a little bit is with the advance and the need of retrofitting buildings. So we've recently developed both non-combustible and wood-framed options for retrofits. So then this is sort of like an expansion of what you need to know for a new build, right? So new build, you need to know all your site conditions, what are the desires for your outcomes. And now this adds the complexity of needing more information about a building that is older and having to collect data. And there's several different ways of doing that, many different ways of doing that. And when the time's appropriate, I don't want to dominate this conversation, but when the time's appropriate, I'd be happy to share a couple guides that have been produced in Canada through Natural Resources Canada and retrofit studies that really help to assess what's needed in the market and what's possible.
Thank you so much. Chelsey, let's talk about geologic, because I know that there's quite a bit of intersection because you're the in-house architect, right? Who is also preparing all the drawings for the manufacturing side. So how do you go about it, and how is your work as the in-house architect different than what an architect that has never worked with a manufacturer, like how's the difference?
Yeah, I think pretty different because, like I said, we have a team of 4 designers and we have a team of 3 shop drawing, and then we've got 24 plus carpenters. So since we've been building these models for a while, handful of years, we have models that we've already built, that we already have the shop drawings data for. So if we have a client that wants one of those kind of off the shelf, and they're not going to modify anything that's going to modify the volume, we can go kind of backwards. We'll approach the shop drawings team, say, hey, can you export your IFC back into Revit? And we will make sure that this Revit model is absolutely accurate. So we can start that feedback loop and minimize having to redraw things. When that happens, it's pretty exciting, but honestly, it's not easy to sell a client on that. So like I said, we're using Revit in our design team. We use the IFC export, and then our shop drawings team uses CADWorks. And so I'm super curious about this other Revit plugin that you mentioned, Jonah. I'm definitely going to look into that because our shop drawings team has been mentioning how the information loss through those softwares is intolerable.
Yeah, Chelsey, I'd love to talk to you about that and get you together with Brian, who does our shop drawings for us. And we have been really happy with it. And we did look at CAD work for a while, but we really wanted to stay Revit native. It was just a big, like the flexibility back and forth. So yeah, but sorry, I don't mean to interrupt, but I just want to share my enthusiasm for that process. Yeah.
Cool. Thank you. I would love to get in touch with Brian. For my design team flexibility, Revit is industry standard. So I hesitate to move away from something like Revit because I might be minimizing their professional goals down the road. But my shop drawings team has been really curious what other software avenues are out there. Angie, what do you know?
So we agree with you. I think Revit's a great communication tool, from us to engineers and other designers. So our design team also uses Rhino. Mm-hmm. So maybe that's something you use as well, but okay. So
in what capacity do you use it? What stage are you using Rhino?
Now, I wish I could say I personally knew more about it, but you can feel free to we can connect you with Brooke, who's our design lead. So we have 4 designers at this time. Brooke's our design lead. And she says she uses 3D CAD software like Rhino to manage the entire design to manufacturing and assembly process. Yeah.
Pretty impressive. I've heard that that's a better IFC export than from Revit, but it's not my own knowledge. It's just what I've heard. But as far as our process, since we do manage, we probably do 1 or 2 outside architect builds a year. And we do upwards of 14, 15 in-house builds, like designs that came from in-house a year. So definitely mostly in-house design, but it's a struggle, even standardizing details, standardizing assemblies. We use the same wall because we serve New England, which is a similar climatic region. We've tried to standardize a lot, and it's still tricky somehow to model it 100% accurate, even though it's in-house. So when I think about outside architects and the struggle that they would have, because they're not as dedicated to it, obviously, as we are, they don't do it every single day. So I think the process is incredibly different. One of the things we have found is the projects that come to us from outside architects are much more complex than ones that we design in-house. We have kind of a small footprint mindset, like let's give you a cozy, good house that is going to fit your family's needs, and then go play outside. So when outside architects come to us and they're just a bit more complex, the structural set is imperative to have, and that means they're working with a structural engineer that we don't work with every day. So having those details, we offer them, we ask them to use our standardized details. Interpreting those is a challenge. And then seeing it come back in their Revit model is not 100% accurate. So that feedback loop from outside architect to our shop drawings team we're working on it. We're getting better. I think we're really working on our SOP, basically. How much information do they need? When do they need it? And basically, as you guys know, earlier the better, and the more information and the better communication, the better. But somehow, like, let's get out of the planning phase and into the construction phase. And everybody wants to push that timeline faster. So yeah, and we're in a really, really cool moment right now at GoLogic also. So we've been building single family residential for the our lifetime. And we're hoping to build a line of houses that is optimized for the experience and the design and panelization. Because right now we're panelizing houses that were stick built 12 years ago, and we're just panelizing them. So we're really trying to work that optimization in, and then we're hoping the next year we'll be able to offer that line that could reach a broader financial demographic is our hope for that. Yeah. What do you think, Abby?
And I love what you're saying there, because it's finding the blend of how to be able to communicate and get people out of their fear factor. So often we'll deal with an architect or an engineer or a developer, and just helping them understand, let's take a deep breath. Let's focus on what's most important. Let's keep it attractive, but let's use a system that's proven to allow you to get there. And I love the fact, we've been dealing with many people that trust in that open collaboration, that willingness. It really goes a long way, because even at Quantum, we've had the hurdle, because we are, certified for cool, cold, and we've done Arctic projects. So, even just the fact of multiple panels that can be, approach many disciplines, that can get overwhelming as a conversation for someone who's stepping right in. But it sounds like we've all had great experience of understanding the people we're working with and where their pain points are, and developing a system in-house that brings them a solution calmly. We've had great success with certain projects. We did a large project for First Nations in Leamington. We worked with A.E. Baird as the architects on that project. They took a lot of our considerations up front, which allowed us to get to a successful project where we turned 28 duplexes and quads in 11 and a half months, which is a quick turnaround. So there are developers and architects that want to bite into this. And I'm glad that there's company like ours and everyone else here that is willing to walk them through it, if they're open to hearing our things we've learned from, the mistakes we've had, our failures that turned into our greatest success stories,
Yeah. Chelsey, one thing makes what you made me think of, and Ilka, around like you talking about like what architects need to know when they're moving into prefabrication. I think what we see, and I think this group would agree, we're all working in this higher performance assembly, like Passivhaus assembly field. So I think some of our communication is unique because of that higher performance, like continuity to your weather barrier, your vapor control layer, and things like that. So a lot of times we're working on educating both the impacts of that form function, like Chelsey, that you were talking about, but also just delineation of what is the thermal envelope and clarity around, like just eliminating standard thermal bridging, which are unique to Passivhaus, like best practice in construction, not necessarily unique to prefabrication. So I think there's twofold there that we're needing to do onboarding for, like that are important to our processes, that are unique to us in this prefabrication sort of sector.
Well, and there's a whole nother player in the mix, right? And that's the structural engineer. So because the load path, a lot of times, depending on design and complexity of the design, is not necessarily integrated into the panel, right? So sometimes it is, and then the engineer really needs to know the panel and how how the assembly is, because and the sequencing, because that is all part of the load path, right? Or it's not within the panel, and then they still have to figure out detailing that allows for thermal breaks, right? They have to be very knowledgeable, exactly what you're saying, not only with the panelization, but also with our high performance goals. And then it also has to be communicated, right, between the engineer. And I'm curious how you all do that, because we've worked with engineers that used Revit and we could kind of import their models. We've worked with engineers that just basically gives us 2D drawings, and we basically have to interpret and put it into the 3D model. So I'm curious about how you do that. But the other thing I wanted to mention really quick too is that the other player is the builder, right? So because even if you assemble the panels, if you take all of that on, there's still the builder on site, and there's overlap in scopes, or scope definition has to be really, really clear. And it also has to be communicated, right? And we found that communicating through that parts-based model that is used for fabrication is very effective. But there are definitely many other ways. Jonah, as you mentioned, you have a whole booklet of like how to deal with these things. So I am curious. I would like to discuss how your workflow is and communication within even softwares with the engineer and the builder.
I'll take a quick stab at that, those are very different communications, I think. Like, so the engineer, we start out with, like, we're very open source, and I'm happy to talk about how we deal with connections, like thermally bridge-free connections between panels that provide an appropriate amount of flexibility for the construction sector, but that sharing like Revit details and very early in on the process. And we do, technical onboarding where we walk through all that process, and sometimes with mixed success, right? What we get back sometimes is very different still, but it's just trying to create as much accessibility to that information as possible. And then on the builder sector, we follow, like, we really appreciate like the 1200 codes from the ICC around offsite construction and design. Like, they've provided really excellent guidelines for clarity between what is offsite work opposed to on-site work, just for clarity in bidding and estimating, in contract management. And so we do follow those. And our assembly sets really look like Lego assembly kits. They're that clear in terms of, like, there's a unique panel designation number, of course, and it's just really clear where it's going and what are the layout parameters. We're providing diagonals and dimensions to assist in the layout process and so forth. So it really is, we don't ever do any of our own installs. It's always trained installers that have gone through our installer training process that are installing, but still, like, every project is unique. So we just really, again, focus on a lot of visual clarity for the builder sector there. And just two other things I wanted to note around, like, design. Typically, like, when we're working on projects that are coming in from an outside architects, aligning, like, what we're looking for is the clear interior dimension, right? Like, because those are the ones that have parameters, and then the wall thicknesses might vary from it. And then the other one is, just a common mistake that we see, or not mistake, but just sort of a missed link, is when we're doing our framing dimensions, it's to the exterior of sheathing, where typically somebody's framing plan would be to exterior framing, and then they're adding sheeting. So, which of course is being used to coordinate foundation layout and so forth. So that's just one thing, like, our layouts are all to the exterior of our panels. And so those are just little things that, that we're constantly sort of needing to catch, because they're, if you've not done offsite construction, then you don't know what you don't know. And those are some just standard assumptions in construction that are normal, but that are different for offsite.
The same as for height markers, right? Do you go from subfloor or finished floor height? So that's also something that has to be clearly communicated. So the drawings between the architect, builder, and manufacturer are all aligned.
Yeah. I can't tell you how many times we've dropped our floor by 3/4 of an inch or 5/8 of an inch, like during the design process for the, yeah,
I have lifted an entire building because the doors wouldn't open
yeah,
otherwise.
yeah. And that's where
Yeah.
I say thank you, Revit.
Hmm.
Honestly, it's that kind of
Hmm.
stuff that's
Yeah. Yeah.
easy.
I'm curious, Chelsey, how do you have an in-house engineer as well, or how do you deal with engineering?
So I'm glad you brought that up because I think on Abby and Angie's team, I saw you guys have an in-house structural engineer. We've been working with the same engineer for maybe a decade. So he's really, really clear about the panelization thing, like parameters that we're working with. But what we're all kind of stoked about is trying to bring one in-house. We don't want to change things regularly. Standardization seems to be the key to keeping this moving, but we do need some iteration. We need some like innovation, like let's think creatively. And it would be nice if we had that same person at the table with us. Have you guys noticed that that has streamlined your process or changed the way you guys build, Abby or Angie?
Well, we're going to provide some clarity on that. Because of the rules and regulations, we do not have in-house. We are working towards in-house because of the requirements for an in-house engineer under the structure of the corporation. So, but we have used dedicated firms that we have started with for like one of the firms I was doing before we even started Passivhaus and Prefab. We had a long history together, and there was a desire for rapid, efficient, energy efficient buildings. So Bradley Engineering, Sarah Bradley, was a key component to getting us started. And with architects Justin Bragg and Harwood Engineering, they've been dedicated to us so that we've been able to field the demand, but also work together in collaboration with our R&D. So everything we do is a very tight-knit partnership. It's very transparent, and it's very motivated to the same vision and outcome that we keep growing into. You know, I was going to mention earlier, hearing some of the stories, when Quantum started our conceptual, let's do this in 2015, you know, me being in the industry for about 35 years in union, non-union, residential, commercial, institutional, industrial, I've practically seen it all. So I knew when Angie and I decided to do this that we were going to have to be game changers. We were going to have to be positive influencers, and we were going to have to be patient. You know, we were talking about the training and education. That's a huge component for us. We were the second training facility in Canada, partnered with Peel Passivhaus and Misu Passivhaus. And we were the first to have a mobile lab where we would take to First Nation communities and we would put our structure up and teach them membranes of a variety of types, window door installations, airtight penetrations, exterior membranes. And we would give them the principles. And we work a lot we have a great quality control program with any of one of our projects where we walk through with their trades, and we're very specific to the area of the structure. I think that's something that gets missed at times with training education. It's a general broad umbrella, very successful and well written and provided, but we know all of our territories have different requirements, different expectations, different ways of applying code. And we focus on that, and it's critical, and we had great success with that. I think another exciting thing Quantum has done, and I don't know, I hope this can be of help to anyone that might need it later. You know, we've walked appraisers through the program of prefab. We've had to walk major banks and construction loans through the process of disbursement and how you have to approach these types of energies. You know, we had one bank one time, it was a fun story where she couldn't put in the consumption when they were doing the income ratio for the mortgage. They couldn't put the consumption use in it because their computer wouldn't go that low.
The energy consumption.
The energy consumption. Thank you, Angie. So, you know, just all those stories are what I hope others would want to look into our companies to see, because we bring that predictability, that efficiency, and that accuracy. I think prefab is a great way for accuracy because you, like Jonah, you mentioned it earlier, you're catching it in the design phase before it gets to construction, or at least we're all doing our best to, right? And Chelsey, I loved what you said there earlier with, being able to monitor as your steps are moving forward. So you're always on top of it. It's not something that sneaks up on us. We have a different approach in the prefab world, don't we?
Yeah, and I think, Chelsey, I actually wanted to go back to your point as well of having a feedback loop, because that is not necessarily something that is really perceived that way, or a lot of times doesn't work that way. It always seems like, okay, the architect does their work and the engineer, and then basically goes into prefab, and then you wait until panels arrive and hopefully everything fits. So, but I think what a lot of times what's missing in that discussion is actually that there is a feedback loop that needs to happen, because not all the time that the architect's design intent actually gets translated seamlessly into prefab. Most of the time, there's something that the architect needs to change, right? Because there is a load path, or there is a different detail that needs to be looked at. And that happens more than anyone, I think, would ever think. So what is the strategy of that feedback loop? And I think you had a really good point. And for you, it's in-house, right? And we work with IFC, and we've done that really, really successfully, where we as the architect had all of a sudden this entire parts-based model in my model, and that was amazing. And I hope that more architects can experience that. But on my side, I couldn't feed back. Right? I couldn't change something and it would go automatically into the production drawings. So I think that is something that ideally would actually happen, right? Where everyone is integrated into that process. And yeah, I think we're running out of time, but maybe everyone can kind of have a little word of how they envision that happening.
Well, we were talking about that in-house, and I think shrinking the time between when the project is finished with design and the team gets on the shop drawings, shrinking that time so that everybody's mind is fresh in the game, and even maybe starting to overlap. There's these levels of development where we're trying to, like, if the level of development is 300 and we know where all the windows and doors are, then let's get that 350 going with the shop drawings and bring that overlap in. That's what we're aiming to do.
Mm-hmm.
Jonah, how about you? What do you think about that?
I think I think it varies, honestly, just because, again, so many of our projects are working with outside architects and engineers, that those firms in that communication can vary widely. One of the things that we have been practicing is that, as Chelsey talked about, going sort of quickly into a preliminary parts layout, so we can run the IFC file through AggieCAD, and it would do all of our preliminary framing just as using standard. It might not have exactly what the engineer needs, or be addressing some point loads within the assembly or something like that, but it'll get 85 or 90% of the way there. And as all of us know, in shop drawings, it's the last 5% that's kind of a bugger, right? It's really easy to do that, the first 90, but it does. I think one thing that we've seen it do is that it starts triggering our other consultants, like say mechanical or engineers, gives them a level of information and to be sort of thinking brass tacks a little bit more. So it's typically only in our commercial projects that we would pre-address mechanical openings and so forth, because those things are not going to be moving. For residential projects, we're training people on how to do penetrations rather than do pre-penetrate, basically, through a shop drawings, just because residential projects, the client is always changing their mind, or the mechanical contractor will be adjusting it, and so, which is totally fine. We want that flexibility, but yeah, that's one thing that we've talked about doing, like Chelsey was saying, is introduce some higher detailed information earlier in on the process that's a little bit sacrificial, right? It's not the beginning of shop drawings. It's just bringing those parts into it so that it can up that conversation. So,
and I know we're short on time. I really want to give appreciation and a shout out to initiatives like the City of Toronto and what NRCan and Cambridge University are doing through their R&Ds. City of Toronto, and Angie could take a second to better explain it, but they took the initiative for the TAF project. Is anyone aware of the TAF program?
yes.
Okay, the Atmospheric Fund.
Yeah, so they're not for profit who put out a call for people to pre-qualify for retrofit overcladding panels. And that was to serve for retrofit bids and retrofit projects and to pretty much promote and build the capacity to do retrofits using overcladding in that area. And they've done a great job. And I think, Abby, you were speaking about Enter Canada and CanMet Energy, their research. They have several research locations, including one in Ottawa that has a joint research facility, which is quite amazing. It's joint between CanMet Energy, which is Natural Resources Canada, as well as Carleton University, and they do a lot of envelope research there. It's actually called CABR, Center for Advanced Building Envelope Research. And it's all information that they do their best to publicize and get out to people. So if you visit their website, you'll see a lot of really interesting information.
And the great thing with the TAP project, we're talking about how to get to project quick, right? Well, this is I am excited to share that Quantum was the only company registered in the program under panelization. And it was a pretty extensive process. But that registration already pre-qualifies stakeholders to a provider. And I think that's an amazing initiative. And I would love to hear if there's programs like this throughout the States. And I would love to collaborate with the other companies on this panel of how we can work on these registrations together.
And even though this is Canadian, they do have like a sample document that can be shared as a starting point for people when they're putting out what specs they would like.
That's right.
So I've promoted it in the past just because for us it was a good guiding document. I think it's good for a lot of people to know about.
Right.
Okay.
Well, thank you so much. Yeah, I think we should probably have another conversation, part 2 at some point. It's been a pleasure talking to everyone. Thank you so much.
Thank you.
Thanks, everybody. Take care.
And that was quite the panel there. I'm not going to repeat all of everyone's names there, Ilka. I thought it was a really fascinating discussion about that whole process of design through to prefab. And I guess that one of the things that stands out for me is that there is a lot of variation even through standardization. There's the whole desire or one of the objectives of prefabrication is to standardize things, which I think works well for some detailing and for some connections and some systems, but there's still a lot of variation between different suppliers, but also some suppliers that offer a lot of customization still of general designs while still using standardized systems. And whenever I hear people talking about visual clarity of the installation process, I jump straight to Lego and thinking about Lego instructions and how great it would be to have, sort of step-by-step 3D drawings of how to put things together for builders who may be on the other side of the country or some distance away, and you're relying on them to put these pieces together to form a house, and everything's got to be done in the right order. And of course, sequencing came up as well as one of the key elements of getting that done successfully. What were the main takeouts for you, Ilka?
Well, I think the whole discussion I thought was just interesting because it always comes back to communication, right? So whatever you do, however you prepare your manufacturing and your installation comes back to how do you really convey all the information that you need. And it basically also goes back to what the architect and the engineer provide to the process, because they start out with design intent, right? And then you have to basically translate that in design intent into something that can be manufactured. And that's basically then the DFMA process. And even within that DFMA process, it's really, really different dependent on each manufacturer, because everyone basically needs to see different information depending on how they build the panels. So sometimes it's people, or it's the manufacturer has an assembly line, and the builders of the panel basically need a shop drawing. So that would be the way to communicate to build the panels. But sometimes they're very, very automated, and then the communication piece is actually a machine files, right? So I find that really interesting. And then beyond really making the panels or components, you have to communicate how it's all being put together and making sure that the sequencing is correct. And I really like your analogies to the Lego sets, because that's exactly what the pamphlets are that you get with your Lego set, right?
Awesome.
Picture by picture by picture, and how to put it all together. And I feel like that's basically the instructions for assembly as well. And every piece, typically every panel, every component has a number, right? And you can kind of follow through and see how they're all put together in reality.
There was a mention of craft, and I quite like this idea that at one end of it's not end of the scale, it's a parallel part of the whole process. You've got quite sophisticated, evolving computerizations. You mentioned like computer files that are sharing data and information like cut files, and there's processing for CNC machines, and there's high level of automation, sophistication. But you still need people who are skilled and experienced, and they have the hands-on experience and do the craft. And I quite like that culmination of modern technology, but also you still need someone who's trained and experienced and skilled in the process of putting physical things together, which I hope continues. I think there will be a place still for robots and pretty sophisticated machinery, but even that requires skilled operators, which I think is hopefully promising for the industry.
What's really interesting, you just mentioned all the software, and that's a big discussion point, right? You might have picked that up in the interview as well, because everyone's trying to find the best software to interact with each other, right? So usually there is one particular software that is really good at creating machine files or this production level model, and they're always like parts-based models. And some use CADWork, which is a really sophisticated software for parts-based modeling, but it is a different modeling software than, for example, Revit, right, or another BIM software. So the question is still like, what kind of software do you use, and how does that integrate with each other? And that was kind of the discussion about how does the architect integrate into that, because mostly the architect is using a BIM software. So what do you export? How do you export? And typically it's an IFC file, but there are limitations to that as well. So even before you get to the manufacturing part, there's still a lot of things that can be streamlined a little bit more in terms of software interchange, and going back to what is important to communicate back and forth.
That's really, because I did hear Revit get mentioned a lot, and I know that a lot of architects use Revit because they like drawing houses, but I also know that mechanical engineers and industrial engineers use more CAD. And with this type of manufacturing of homes, we're talking about both. And so something needs to connect those two in the middle to take the vision of the house down to the individual components and how all that comes together. So, I can see that being an interesting technological challenge.
Yeah, and you basically, before you start a project, you really have to see where everyone is coming from and what is the best way to align everything, because everyone is comfortable in what they're doing and they don't really want to learn something else. So how do you incorporate everything in the most streamlined way? So, but that's why a lot of times, like what Chelsey and Abby and Jonah, they're all talking about, it is the more you kind of integrate team members into your process, either very early on, or you have in-house architects, in-house engineers, you can align your process that way, because you can align whatever software you're using, because then you can require certain software, right? You can't really do that if you're working with outside architects or outside engineers. So there again, different approaches to the process.
So, Ilka, you talked about getting everyone on board, and one thing I picked up on, there was a brief mention of finance and banks, and it makes sense that you've got to think about getting all the designers and the traditional parts of the building process, and even sometimes the developer or who's going to be using the building. That's all part of the integrated design. I think that's really interesting here. Thinking also about financing, and also I know that this is an issue in my part of the world where there's lots of requirements from a building authority who has to sign things off at certain stages. And in a traditional build, that means you get someone to come on site and check that the framing is all good before the insulation goes in, and then they come back and check the insulation is all good before the lining goes on. If all that's being done in a factory and everything's come as a sealed panel, then that has implications for getting sign off and getting everything checked off by whoever needs to check it off. But there might also be progress payments that are reliant on certain traditional stages of a building project. And that all looks completely different if everything's turned up flat pack to a building site. So it requires a little bit of different thinking, both from a policy, rules and regulations perspective, but also a financing perspective. It's kind of shaking up the whole industry from all angles.
Yeah, absolutely. You're making a lot of good points. The financing part is very, very different. And I think that's why sometimes manufacturers do have a hard time really making all the finances work. It's not necessarily because they can't make it work. It's just a timing of when the money is coming in, because they have to have everything, all the material up front, right? They're building the absolute, like the full house basically up front, and then they deliver it. And if you're a builder on site, you can do it in stages, right? You buy the materials in stages. So there's absolutely a difference in money flow basically, and that the banks have to understand that as well. And then in terms of regulations, that is something that's really important to know beforehand, because some states like Pennsylvania and New Jersey, they require a third-party review process, and sometimes even the factories have to be basically going through that process before they can produce panels. So, and it actually goes back to a review process that affects the architect and the structural engineer of the project as well. So again, like, I think the more you know upfront of what you're getting into, the better it is, because then you can prepare and set certain expectations, and also set up your contract in a certain way. I mean, even for an architect, it's the process is quite different, because a lot of the work that you usually do on site as construction administration, you actually do that if you work with a panelization or pre-manufacturer. You as an architect are doing a lot of the CA work up front, like doing design development phase. And if you have your contract set up in different stages and may get paid either per stage or hourly, that can really affect how you're getting paid as well. And I'm sure that's very similar to structural engineers.
Definitely. Lots of stuff to think about, and really good to hear from different perspectives of how people are achieving good outcomes and achieving Passivhaus with lots of different details and different ways of doing it. Thank you very much for that, Ilka. Really great. I know it can be challenging sometimes bringing a bunch of people together like that, but well done. Zach, what have we got coming up?
Yeah, it's a big week this week at the Passivhaus Accelerator. So on Wednesday, December 4th, we have a 101 series of Passivhaus Accelerator Live, or 101 edition of the Live, called How to Reduce Embodied Carbon with Elizabeth Boudinot. So December is essentially embodied carbon month for us at the accelerator. And November, by the way, November was prefab month. So this podcast episode and interview is a great way to kind of close that out. And if you're interested though in catching other great stories and examples of passive prefab, you could check out our YouTube channel. The Passivhaus Accelerator YouTube channel has recordings of the presentations that were happening throughout November about prefab. And of course, we've got great episodes on the podcast as well. So don't miss this Wednesday, the 101 series about how to reduce embodied carbon as we embark into this new theme at the accelerator for December. And then Friday is the big day. That is the Reimagine Buildings Biomaterials Conference. And they were co-producing this with RMI. We've got a great roster of speakers, and we've organized this program in very close collaboration with Chris Magwood, a North American leader, really global leader in embodied carbon. So we'll learn about all of the cool materials that are available and case studies and examples of how those materials are being applied in the real world. So lots of great stuff there. You can register for that either by becoming a member of the Reimagine Buildings Collective, because all of our Reimagine Buildings conferences, these are online conferences, all of those conferences are part of membership in the Reimagine Buildings Collective. So you can do it that way, or you can register a la carte for the conference only. So, and it's actually the same cost for 1 month of membership or for the conference a la carte. So we hope that people will become members and check that out. So, and we'll have a link in the show notes about that. And then speaking of the collective, we will be joined by Jacob Deva Raghusen on Friday, the 13th of December. And Jacob plays a lot of roles in building decarbonization. He is lead embodied carbon researcher and beam trainer with Builders for Climate Action. He's the director of building science and sustainability at New Frameworks. And he's also really involved in the Bio-Based Materials Collective. He'll be one of the speakers at Reimagine Buildings Biomaterials on this Friday, but we'll have a Ask Me Anything session with Jacob in the collective at noon Eastern on Friday the 13th. So if you want to dive deeper with a tremendous human being and expert in embodied carbon, you'll have that opportunity to do that.
Wow, so much going on. I'm really looking forward to that biomaterials workshop and that whole conversation, thinking about not just how can we make buildings perform really well, but also use materials that we can do something with after the life of the building, or can serve some other useful purpose without being environmentally detrimental during the construction and building phase. So really interesting stuff. Looking forward to that. Lots going on. Thank you, Zach.
Absolutely.
Thanks again, Ilka, for all your great work out there and collecting lots of really great interviews. And we'll chat again soon.